Good afternoon, class. I hope you're doing well. I wanted to complete one more practice problem with you today. So I want to show you how to calculate the total energy of an object that is orbiting the Earth. So when I say total energy, this is going to be the sum of the gravitational potential energy of the object and the object's kinetic energy. So let's go ahead and get started. Calculate the total energy for a 175,000 kilogram shuttle orbiting the Earth at 600,000 meters above the Earth's surface. So let's go ahead and write our knowns down. The mass of the shuttle is 175,000 kilograms. The altitude, so the altitude is identified by d sub 0. This is 600,000 meters. And what we need to do is go ahead and draw a simple picture to help us solve this problem. So this is the radius of the Earth identified by r sub e. And then our space shuttle is at an altitude, and I'm going to represent the altitude as d sub 0. And the sum of these two values, this is going to be the center to center distance between the space shuttle and the Earth, and it is identified by a capital R. Okay, so to calculate the total energy of our system, it's going to be sigma E. So the Greek letter sigma means sum of, so the sum of the energy is going to be the negative universal gravitational constant times the mass of the shuttle multiplied by the mass of the Earth divided by 2 times R. Now R, remember R is the sum of the radius of the Earth and the altitude, so this is the base equation. But what I want to go ahead and do, instead of writing R, I'm going to expand it and say d sub 0, so the altitude plus the radius of the Earth. So from here, we can go ahead and plug in some values. So the total energy of our system, I've got a negative 6.67 times 10 to the negative 11th. Our units are meters cubed per kilograms second squared. Then we have the mass of the space shuttle, 175,000 kilograms. And the mass of the Earth is 5.98 times 10 to the 24th kilograms. And we're going to divide this by 2 times d sub 0, this is my altitude, which is given at 600,000 meters, plus the radius of the Earth. This is going to be 6,378,000 meters. So what let's go ahead and do is take out our calculator. Let's resolve the numerator. And let's just write the numerical value first, and then after we do that, we'll go ahead and take a look at our units. So, in the numerator, our universal gravitational constant, now we do need to apply our negative sign here. We're going to multiply this by 175,000. And then that answer we're going to multiply by the mass of the Earth. And I get 6.98015 times 10 to the 19th. Now, pretty big number, but let's take a look at our units here. So I have meters cubed per kilogram second squared times, we have a kilogram times a kilogram. This is going to be kilograms squared. And algebraically, we can write that as kilograms squared over 1. So we can see that one of our kilograms is going to cancel. And I'm going to have units of kilogram meter cubed per second squared. Okay. All right. So right here, let's go ahead and take care of our values in parentheses. So this is going to look like 6,978,000 times 2. And we can add our units here. I mean, we can add our values here because we have like units. So in the denominator, I have 13,956,000 meters. Okay, so let's go ahead and divide right here. And I'm going to get, sorry, we have a negative value here. So the sum of the space shuttle's energy, and remember this is the kinetic energy of the space shuttle and the gravitational potential energy of the space shuttle. So I get a negative 5.0015. Now let's take a look at my units. So whenever we divide fractions, it's like multiplying by the inverse of the denominator. So I have kilogram meters cubed per second squared multiplied by the inverse of the denominator, 1 over meter. This is going to give me kilogram times meters squared per second squared. Now what I want to do here is factor out one of my meters. So I have a kilogram meter per second squared times meter over 1. And we know that a kilogram meter per second squared is equal to a Newton. So what we have is a Newton meter. And you know a Newton meter is equal to 1 joule. So our units are in joules. So our answer for the total energy of our space shuttle, we have negative 5.0015. And I'm sorry, that is times 10 to the 12th. Joules. Thought that number was a little bit less than what it should have been there. So, all right. So this space shuttle has a lot of energy here. So total energy, right there. So if you have any questions about this this practice problem, I believe it's number 3 on the first orbital mechanics assignment that I've loaded up for you, send me an email and I'll help you out. I hope you have a wonderful day.